Hi there, hope you have a fantastic day today. This lesson, I will teach you relative error and percentage error. Before I start, just to let you know, on the description below, there is a link so you can access the PDF file as well. And don't forget to give me a like and subscribe if you haven't done so you can help me to grow my channel. So let's go straight into it. What is a relative error? So a relative error can be calculated by absolute error over the measurement. From last video, we know that the absolute error is always equal to plus or minus a half of the degree of accuracy or limit of reading, if you like. So if you're not sure what it is, not to worry, I will go through an example with you and you will understand what I mean. Now, what is a percentage error? A percentage error is exactly the same as relative error, except relative error, we just make it into percentage. That will becomes percentage error. In another word, to calculate percentage error, we just use relative error, we times by 100%. So we just convert relative error into percentage. That's all it is. Now remember, when you convert to percentage, always times by 100%, not times by 100, okay? Because 100% is 1. But if you times by 100, it's actually 100. So for example, 5 is equal to 5 times 100%, which is 500%. So 5 is 500%. But if you use 5 times 100, is actually 500. So 500 is different from 500%. Okay, so just to make that clear for you. So let's go through an example. So first one. So let's say the calculator here is measured as 15.6 centimeters. So what is the relative error in this measurement? So remember, so first of all, we know that to work out the relative error is actually equal to the absolute error over the measurement. So first of all, we need to work out the absolute error first. So how do I work out absolute error? Remember, absolute error is always equal plus or minus a half of the degree of accuracy or the limit of reading, if you like. So in this case, the limit of reading is 0.1 centimeter because it correct to 1 decimal place. So if you think about it, the measurement of this is 15.6 centimeters. So therefore, the next reading it should be 15.7 and followed by 15.8 and 15.9 and so on. Okay, so it correct to 1 decimal place. So therefore, the degree of accuracy or the limit reading is 0.1 of a centimeter. So therefore, let's work out the absolute error first. So the absolute error is equal to plus or minus a half of the limit of reading. So the limit reading of this is 0.1 of a centimeter. So times by 0.1. 0.1 times a half, which will give me plus or minus 0.05 centimeters. So this means that the error could either go maximum, which is the upper limit, is 15.65 centimeters, or the lower limit is 15.55 centimeters. Okay, so that is lower and upper limit. But at the moment, we just need to work out the absolute error. So which is 0.05 centimeters. Now to work out the relative error is equal to the absolute error over the measurement. So the measurement in this case is 15.6 centimeters. So therefore, we just work out the relative error. So the relative error is, I just write this down, which equal to the absolute error, which is plus or minus 0.05 divided by or over 15.6 centimeters. So 15.6 because 15.6 is the measurement. So now I just put on a calculator. So I go 0.05 over or divided by, if you like, 15.6. So that is equal to 0.05 0.0032. Okay, so is equal to 0 point plus or minus 0.032. So this is a very, very small number. Okay, now second part. So to work out the percentage error, we know that the percentage error is the relative error. We just need to convert into percentage. That's all. So when we convert to percentage, we times by 100%. Okay, so let's just write here percentage error is equal to, so we just change the relative error into percentage. That's all. So which is plus or minus, that is the relative error 0.0032 times by 100%. So make sure you put the percentage size next to 100, okay? Because you times by 100% means times by 1. So every time you times by 100%, that means you times by 1 only. So it's the same, okay? So remember that for me. So that give me plus or minus 0.32%. So that is the margin error, if you like. So the percentage error is quite small because it's only 0.32%. Now, please stop the video and try this one yourself. Now, part A. So to work out the relative error, step number 1, we need to work out the absolute error first. So to work out the absolute error, we know that is always plus or minus a half of the degree of accuracy or the reading, if you like. So the limit of reading in this case here is 1 gram, okay? Because the next reading after 104 grams should be 105, 106, 107, and so on, right? So the limit of reading is 1 gram. So the absolute error is equal to plus or minus a half of 1 gram. So that will give me plus or minus 0.5 of a grams. So the error could either go up 0.5 of a gram or go down by 0.5 of a gram. Okay, so just remember that. The plus or the minus sign just show that the mistake could either go up, which is above 404 grams, or 0.05 of a gram below 404 grams. That's all. So to work out the relative error, relative is equal to absolute error, which is plus or minus 0.05 over the measurement. So in this case, the measurement in this case here is 404. So now I just put in a calculator, that's all. 0.5 divided by 404. So that is 0.0012, correct to 4 decimal place. So 0. I just write it down first. So that is equal to plus or minus 0.0012. And to work out the percentage error, all we need to do is we just need to convert the relative error into percentage. That's all. Okay, so remember that. So otherwise, we just use the formula. So the percentage error is equal to the absolute error over the measurement, and you times by 100%. And then we'll give you an answer. Okay, since we work out relative error already, we just convert that into percentage. So percentage error is equal to, so plus or minus 0.0012 times by 100%. So that will give me, so just move 1, 2, so plus or minus 0.12%. So the plus or minus sign to show that is 0.12% above the measurement, or it could go 0.12% below the measurement. That's all it is. Okay, so when you work out the percentage, if you don't write plus or minus, and it is still correct. Okay, just keep that in mind for me. Last questions. Please pause the video and try this one yourself. Hi, I'm back. How did you go? So let's work it out together. So the relative error. So first of all, we need to work out the absolute error first. So absolute error is equal to half, okay, plus or minus half of the limit of reading. So plus or minus a half of the degree of accuracy, if you like. In this case is 0.1 because it's correct to one decimal place. So at the moment, the reading is 146.2 liters. So the next reading should be 146.3 and 0.4, 0.5 and so on, right? So therefore, the limit of reading is 0.1 of a liter. So therefore, which is plus or minus a half of 0.1 of a liter. So that will give me plus or minus 0.05 liters. Then we just need to work out the relative error by using the absolute error over the measurement, okay? So relative error, so which is equal to the absolute error, so which is plus or minus 0.05 over the measurement. So in this case is 146.2. So now I just use calculator to work this out. So just go 0.05 divided by 146.2. So 0.003. So the answer is equal to plus or minus 0.0003. Now to work out the percentage error, so we need to convert the relative error into percentage. Otherwise, you just use absolute error over the measurement times by 100%. Okay, so we'll give you the answer straight away. So we just go percentage error is equal to plus or minus 0.0003 times by 100%. So that will give me move 1, 2. So which is plus or minus 0.03%. So therefore, the margin of error is very, very small because it's just 0.03%. Okay, so it's either 0.03 above the measurement, or it could be 0.03% below the measurement. Okay, that's all it is. So hope you got it correct. Okay, so thank you so much for watching. Bye.